wrote down solution for a system and what a system is. So just a system of equations. It's a set of two or more equations that have the same variables. Now, in the past, you've probably kind of exclusively dealt with two equations with two variables. As we get going in this unit, we're going to do three equations with three variables a little bit later on, but we're going to start with what we call a 2 by 2. Means I got two variables, usually x and y, and two equations. Now, your solution, which is what we're going to look at today on the graphs, is just any set of values for the variables that make all the equations in your system true. And then today we're going to start with solving by graphing. Okay, now these first couple questions, if you're looking at them, the actual answers are not on nice numbers. So I'm not asking you what the solution is. This just literally says state the number of solutions. Like, so how many solutions, not what they actually are, because they're not actually on nice points. So if you're looking at a system, or if you're looking at a graph, it's got two equations on it. What am I looking for in terms of like what would be a solution? What would that look like visually? Yeah, we're just where they cross. Okay, so if I look at that first picture, how many solutions do we have? Just one, right? We got two lines, they just intersect in one spot. So there would be one solution there. Now, the picture I have right next to this has a parabola, that's the U shape, also called a quadratic, and a line. How many solutions would you tell me that system has? Two, because you see the line crosses the parabola in two different spots. Now, I've got two lines on my last system. How many solutions does that last picture have? No solution. Those two lines are parallel and they don't touch each other, so I don't have any solutions in that because those two lines don't share any points, so no points in common. Okay, now we're just going to focus on linear systems, meaning equations of lines, in this first example here. So I'm just going to grab two different colors so I can kind of highlight which line is which. But we're just going to graph these like we were doing in our first unit. We just reviewed like y equals mx plus b, so we're just going to kind of apply that here. So if I graphed y equals 1/2 x plus 3, right? You'd start at 3, make sure you're on your y-axis, and then I use my slope. So my slope is 1/2, so I'm going to go up 1 over 2 to the right. Now, and you don't have to do this, but I usually, if I'm solving a system by graphing, I will graph maybe more points than I normally would if I was just trying to sketch the line, because what I'm ultimately going to try to see here is if these two lines intersect, what's the point that they have in common? And I promise, if we're asking you guys to solve a system by graphing, the intersection will be on a nice point. Okay, if we're asking you to graph and you get a weird, like they don't cross in a nice spot, it's probably going to be a situation where we would use an algebraic method to find the answer instead of graphing, because there's different ways to solve these. So if you're being asked to graph it, I promise they should intersect in a nice spot. Okay, so then my second equation, y equals negative 1/4 x minus 3. So I'm going to come down to negative 3 on my y-axis. And I just automatically, when I have a negative slope, I go down 1 and then here 4 to the right. But as I do that, I'm kind of seeing I'm moving away from the line. I want to see where this intersects. So I would actually go backwards. I would go up 1 and left 4. And I'm going to repeat that one more time, up 1 and left 4. And then I ended up drawing right on top of one of the lines, or sorry, one of the points I kind of had in there for the other line. And that's what you're looking for. So what point do these two lines have in common? Can you guys tell? -8, -1. That's going to be my answer. Okay, now I'm going to just go below the graph here really quick and give you just a little vocabulary term. This graph right here is an example of what we call an independent system. Independent system, if you've got two linear equations, always happens if the lines intersect. So all you got going on here is intersecting lines. And if the lines intersect, you will always have one solution. So any type of independent system should be a set of intersecting lines, and they'd only have one point in common. And this will happen anytime the two lines have different slopes. That's the only requirement. If you're going to have a system that has one solution that's two lines, the two lines are going to have different slopes. Doesn't matter about the y-intercept. Just as long as the slopes are different, the lines will run into each other somewhere in one point. Okay. Sorry, I should have spaced this a little bit better. Okay, let me come back to this one. Now, I'm going to try and graph. This first one's in mx plus b form. So I got y equals negative 2x minus 1. So I'm going to go down to negative 1, and then I'm going to go down 2 over 1, down 2 over 1, just a couple of points in here. And I usually wait to play connect the dots until I get the other graph on the system. Now, what I would recommend for this other graph, we could maybe, it's in standard form, use intercepts, but as I'm looking at that, my x-intercept, if I would divide 5 by 2, is going to be 2.5, and I don't really want to estimate that. So what I would recommend there for that second equation in the system, I would just do, it's just one step. I'm just going to subtract 2x from both sides and write that negative 2x right after the equal sign. Just kind of slide that positive 5 over, and that'll be that second equation, but in slope-intercept form instead of standard form, like it was typed there, and then it's usually a little bit easier to put on the graph. So then that guy, I'm going to start at 5, and I'm also going to go down 2 over 1, similar to what I did on the last equation. What would you guys tell me the solution is for this lovely system? No solution, right? These end up being parallel lines. Those two slopes were the same, so this is no solution. All right, now just to give you a vocabulary term just directly beneath this, if your lines end up being parallel, this is called inconsistent system. Inconsistent system, that's the vocabulary term. That's going to be whenever you have parallel lines. And whenever you have parallel lines, obviously, they don't run into each other, so they don't have any points in common. So anytime you end up with parallel lines, you're not going to have a solution. Now, if you didn't have a graph, algebraically, it would have the same slope, but it would have to have a different y-intercept to have that happen. So anytime you got parallel lines, you got the same slope, but they have to have a different y-intercept. Okay. Now, the last one, these are the three possible things that can happen if you are graphing a system of two lines. All right, I'm going to graph the first one. Y equals negative 1/3 x plus 3, so I'm going to start on 3 on my y-axis and just go down 1 over 3 to the right. Or you can go backwards, you can go up 1 and over 3 to the left. Just one of those directions is negative. That ensures I get a negative slope. And kind of similar to the question we just did, that second equation is in standard form. I would just recommend real quick here, I'm going to get this in slope-intercept form. I'm just going to get y by itself on one side. So to do that, I'm just going to move the 2x to the other side. I'd have negative 6y. I just slide that negative 18 down. Just put the 2x right after the equal sign, and that'll make it look more like slope-intercept form. And then everybody gets divided by negative 6. Everybody on both sides. What would 2 over negative 6 reduce to? Negative 1/3. All right, so there's my slope, negative 1/3 with the x next to it. And then negative 18 divided by negative 6 would give me what? Plus 3. Okay, now, what did we notice about that? Yeah, I didn't see that, like right when I started that problem. I didn't go, oh, obviously those are the same lines. So I did a little algebra to get that. So it might not be real obvious to you, but these are actually the same equation. They're just in two different formats. This originally was in standard form. This was in slope-intercept form. So when I got them in the same format, we could see it. If you were to graph this, this would literally just be one line right on top of the other because they're both the same equation. So it'd be one line graphed right on top of the other. Does anybody know what you would write down for your solution there? Yes. Yes. a line has an infinite number of points. So if I've got a line graphed on top of itself, they have every point in common, so there's infinite solutions here. Now, the name for that lovely system is called dependent. So anytime the two lines actually end up being the same, and usually when you're presented with a question like that, they're not going to be both in the same, like slope-intercept form or standard form or whatever. You'll have one of each, so you might have to do a little algebra to manipulate that. That is always a situation where the two are just the same line. And solution there is always infinite solutions. Anytime you have the same line, like I said, you might have to do a little algebra, but it's going to have infinite solutions. And I can spell it, I promise. Okay, is anybody having a question? All right. Now, the next problem I have here is not a graph. I just have for you a system. And right above the system, it says, is 4-2 a solution to the system? So I'm not going to graph this. How would I just determine if that point 4-2 they give me, how would I determine if that's a solution? Exactly. We're just going to plug it in to both equations, right? Okay, so you're going to see if it makes the equation true. It's if you have a solution to a system, it has to make both of the equations true. I'm just going to grab two different colors. So everywhere I see an x, I want to put in 4. Everywhere I see a y, I'm going to put in 2. So for that first equation in the system, I don't know why I just wrote an x. Okay, we're going to do 4 plus 2 times y, my y coordinate's 2, and that first equation is set equal to 8. So we're just checking to see if this is true or not. So this would be 4 plus 4, so 8 equals 8, right? That's for sure. Bless you. Okay, now you got to check both. So the second equation is 2x, so I'm going to do 2 times 4 minus y. The y is 2. I'm just subbing in the x and y coordinates for x and y, and this equation would be equal to 6. So then we're seeing if this is true. So I get 8 minus 2 equals 6. 6 is equal to 6. So that's also true. So what would your answer to the question be, yes or no?
Yes.
Yes. All right. So it has to work for both. If one of these, if you worked it out and it wasn't equal on both sides, then your answer would be automatically no. It has to work for both of them. If it works for one and not the other, it's got to be no. If it doesn't work for either one, it's got to be no. All right. Does anybody have a question? Okay. All I'm going to do down here at the bottom is see if you guys remember how to graph horizontal and vertical lines here real quick. So each system in this last example either involves some horizontal line or some vertical line or maybe both. And the first system I've got just plain y equals 8, no x involved. The second equation, x equals -3, no y involved. Does anybody know what the solution for that system would be? There is a solution. Does anybody know what it would be without graphing it? Yes. How do you know?
Because the x is -3 and the y is 8.
Yeah, they literally tell you x is -3 and y is 8. So to fit that requirement, they're giving you one of each. If you actually graphed it, and I know this trips people up sometimes. So y equals, I call it horizontal because it's a horizontal line where all the y coordinates are going to be 8. So I just sketched that real quick there. All those y coordinates are the same. X's change as you go left and right, but all the y coordinates there are 8. And then I've got x equals -3. I call that vertexal because it's a vertical line where all the x coordinates are -3. And then you guys can see that intersection, right? The x coordinate had to be -3, the y coordinate had to be 8, so that's going to be the point that those two lines have in common. All right, the system next to this says x equals 0, x equals 5. Can you tell me the solution without graphing it for that next picture? No solution. Are these, why you say no solution? They're both vertical lines. These guys are going to be parallel. Now, I know this is also another thing that trips people up. So x equals 0 is actually the equation of the y-axis. So x equals 0 is actually, I'm just putting my marker right over the y-axis. All those x coordinates are 0. The y coordinates change as you go up and down. X equals 5 just be over here to the side just a little bit. Another vertexal line. All those x-coordinates are 5. The two lines never touch each other. They don't have any points in common, so no solution. Okay. And now I have the last one, or last two down here. One of them has a parabola. We'll do this other one first. So this third picture in this example, I have y equals -1, and then actually just slope-intercept form, y equals 5/2x plus 4. Can anybody tell me the y-coordinate of the intersection without graphing it? -1. They're telling you right here the y-coordinate has to be -1. So I know that without even graphing it. Just trying to give you like a little quick kind of a heads up on that. So let me put that on the graph here. Nice horizontal line at -1. Now the other equation is just mx plus b. So let's just put that on the graph. I would start that guy at 4. And my slope's 5/2. So I'd go up 1, 2, 3, 4, 5/2. And as I kind of do that, I see I'm kind of going away from where I want to see the intersection. So I'd actually go back to that y-intercept, and I'm going to go backwards. I'm going to go down 5, 1, 2, 3, 4, 5, and then left 2. If you go down and then left, those are both negative directions. It'd be like a negative divided by a negative, cancel each other out. And there you can see where those two lines are going to run into each other. I already knew the y-coordinate had to be -1. The x-coordinate looks like is -2 at that point. Okay, and I just have one more. We have not done anything with quadratics so far this year. We'll do a whole unit on it, but that first equation in the system's graphed for you. So this is x squared plus 2x minus 4. You should not have to graph anything by hand yourself in this unit. That's a parabola. The other equation, though, is not graphed, and that is the x equals -4. So you are just going to see where this intersects the graph that's already on the picture there for you. So I'm just going to draw a nice vertexal line at -4. What would you guys say is the solution, if there is one, for this last one? What'd you put? -4, 4. Okay. Is anybody having a question?